All right, now we're moving on to dynamite plots. So in that first section where I talked about the best practices for statistical graphics, I gave a little bit of a sneak peek that dynamite plots really are often not ideal because they mask the underlying data, but they're pretty common in the medical literature, so we're going to go ahead and discuss them. So here's an example of a dynamite plot, and these plots are most typically seen in basic science papers, but they're seen kind of throughout. So a dynamite plot typically shows the relationship between two variables, a continuous variable that have values along the vertical or the y-axis, and a categorical variable that has values along the horizontal or the x-axis. And so the main purpose of a dynamite plot is often to compare group means. So going back to that table 1 example, instead of displaying the interquartile range like a box plot, the dynamite plot is graphically displaying the mean and the standard deviation of a continuous variable. So the top of each bar, I've highlighted here with a green dashed line, is the mean value for that group or category. And then these lines above and below that make the bars look like little sticks of dynamite, those represent the uncertainty. So often this is the standard deviation of the continuous variable for each group. So the dynamite plots, as we've sort of briefly mentioned, they suffer from a lot of the same pitfalls as the box plots in that they're graphical displays of summary measures, and so they often mask the true distribution or the shape of the data. And so again, the data can be different from what the bars imply. For example, if this is a chart that is displayed, it can be assumed that the points occur throughout that entire bar. But I can overlay some actual data points and you can see a pretty different picture. So the two of the variables really only fall right along the mean, and that middle one is much more spread out. So the bars, I think, kind of imply that there's data throughout that whole space, when in reality, that's not necessarily the case. And so again, kind of overlaying that data or using statistical graphs that really show the data itself can be really useful for being able to assess what's actually going on. And the other problem, like with box plots, is that the sample size in a dynamite plot can be masked. And so here I've overlaid the sample size, and in the extreme example, that far left plot really only represents 5 individuals. And so it can be really important to understand the underlying data that make up these dynamite plots if they're seen in the literature. And so you should really be looking elsewhere in the article for information about the sample size if it's given, so that you can make a better assessment when looking at the plots themselves. Okay, so here's an example of a dynamite plot out there in the wild. And this is a study that is examining the influence of uncertainty on framed decision-making with moral dilemma. And so the light blue bars here indicate the gain framing, and the dark blue bars indicate loss framing. And the plot on the left shows the certainty condition, and on the right shows the uncertainty condition. So if you want to read more about this study, you can find it in PLOS Medicine. But just for now, let's look at what's going on in this graph. So the y-axis, which is the continuous variable that's being evaluated, is the mean moral acceptability score as a percent. And there are a few additional things to notice here. So the vertical lines above the colored bars, they actually represent 95% confidence intervals. And I know that because I can see it in the text below the plot. It says bars represent 95% confidence intervals. So instead of standard deviations, this is showing a confidence interval. And additionally, notice that there are these 3 stars above the left graph and NS above the right. So sometimes stars like this are included to signify statistical significance. So that identifies the difference in framing was statistically significant among the certainty condition, but not among the uncertainty condition. All right, so let's interpret this plot. Basically, we can interpret this as saying that there is an effect of framing, gain versus loss, among the certainty condition, but not among the uncertainty condition. And in the certainty condition, the framing of gain had a higher moral acceptability score than the framing of loss.